In this question, Polycarp wants to visit his friend who lives at point x equals a, and he's currently at x equals 0. And he wants to reach his friend while being fully dry. So we are given n segments such that over these segments it's raining. And then we're given m points at which he can pick an umbrella that has a certain weight. And from moving from a point to the next point with an umbrella, that adds a fatigue value which is equal to the weight of the umbrella. So what we want to find out is what is the least amount of fatigue Polycarp can achieve while trying to get from his house to his friend's house while being completely dry. And if he can't reach his friend's house while being fully dry, he just outputs -1. Okay, so the input. So we're given integer a, n, and m. Oh wow. Okay, and first thing first, we are given a list of n segments such that it's raining. And we're given, like here, it's raining between 3 and 7. So what we can do is we can have some array, let's just call it rain, which is a boolean, or the maximum value can be 2000. So let's just make this 2001 to be safe. And if like rain I is true, it means that from point I to I plus 1 it's raining. So then we're given L and R, so left and right, and then for I between L and R we just do rain J equals true. And this is R, not R plus 1, because for example here, right, so from 3 to 4, so if index I is true, that if index 3 is true, that means from 3 to 4 it's raining. If 4 is true, 4 to 5 is raining, all the way until 6. And if 6 is true, that means between 6 and 7 it's raining, which is true. But if we did R plus 1, then that would mean that the rain of 7 would be true, but 7 to 8 is not raining, or like we don't know that in this piece of info. So therefore it's only R and not R plus 1. So then the next m lines, we get m umbrellas and we get their weight and at which index we find them. So x and p. So this is going to be the index we get them at and their weight. So let's just create a pair, because we're given 2 inputs to store all this info. So it will be pair int, and we'll call this for umbrella, again of size 2001. So then I dot, oh it's not I is just going to be equal to the index and the weight. So for each umbrella we have easy access to its weight and where we find it. That makes sense. So now what we need is this huge DP array to solve this. So how this will work is, let's say DPI, let's do JI for now. So what does this mean? The J indicates the jth umbrella from this index. So it'll be the 0th umbrella, the first umbrella, the second umbrella, all the way in here. And this has m entries. So this goes all the way from 0 to m minus 1. And then dp of m would be, we're looking at the mth umbrella, which doesn't exist. So it'll be the case where there is no umbrella at all. And then here I will be the current point, right? So dp of 4, 3 would be, we'll be looking at the point such that at the ith point we're using the jth umbrella. And like if dp of 6, 5 would mean at the 5th point we're looking at the point, we're looking such that at the 6th point we're using the 5th umbrella. Yeah, so that was what I say, dp6 5. Yeah, so at the fifth point we're using the sixth umbrella, and we'll see what is the lowest fatigue if that's the case. Okay, so we need to calculate the previous fatigue. Yeah, in the previous in the previous point, because let's say it's not raining currently, but it was raining in the previous point, then at when j equals m, so currently we're at the mth umbrella, which means we aren't using any umbrella at all. Since it's not raining, we will have a answer that's less than infinity, hopefully. And to do that, that'll just be the lowest value of fatigue we have in the previous point, and that's it. So that's why we always have to keep track of the previous min, just in case there's a point, there's an area such that it's raining and then suddenly now it's not raining. So yeah, that's previous min. So then for I, so we go through all the points and we go through all the umbrellas, and it's +1 because again when j equals m we aren't using any umbrella, and for each iteration we have to keep track of the current minimum here. Okay, so if j is less than m, which means we're using some umbrella, then we check if of I dot first, so the first one is the index. So if this index is equivalent to I, then dp of ji is equivalent to previous min plus j dot second. So what does this mean? So if this is the first point at which we use this umbrella, so this means we pick up the umbrella at this point. The lowest fatigue we can get if we are using this umbrella at this point would be the lowest fatigue in the previous point plus the weight of our current umbrella. Then otherwise, if we can use this umbrella, but it's not the first time that we see it, then dp of ji is going to be dp of ji minus 1 plus j dot second. So in this problem, if we drop an umbrella, we can't pick it up again, right? So if we are using an umbrella, we're using it from that point onwards till the very end. So if we're using it at a point such that we don't pick it up and we picked it up somewhere in the past, then the current fatigue that you'll get is the fatigue we had in the previous round, assuming that in the previous round we had this umbrella plus the weight of the umbrella to count for this point. So that's why we need this. So otherwise, if it's not j less than m and j is equal to m, it means we're not using any umbrella at all. So therefore, if it's not currently raining, so if it's not currently raining, then dp of mi is just going to be the minimum of dp of mi and previous min, right? Because if it's not raining, then there's no weight that you're going to add on. It's just going to be the lightest fatigue you have at the previous point. That's correct. And then at the very end, you always want to calculate the current minimum fatigue for this round, which will be current min is equivalent to min of current min and dpij. Okay, and then after this for loop, we can calculate our, the new previous min just becomes our current min. That makes sense. And now that we have this, initially let our answer be infinity, and then we go through all the umbrellas at the very last point, and then we want the lowest value of that. So it will be minimum of our current answer and dpi a minus 1. Yeah, so this will be like when we reach this home, what is the lowest fatigue we get? So we look at the the m plus one umbrella, the m umbrellas, and the option that we don't use an umbrella, and then the lowest of that should be our answer, and then we simply just see out. Oh, we check if the answer is infinity, then we know no such answer exists. Otherwise, we just output answer, and that should work. Oh, I'm shadowing. Okay, yeah, it should be clear. Oh, DP. Okay, let's test F. Oh, okay. So it's 0 because DP here, since we did outside the scope of anything, it sets everything to 0. So at the very start, we have to memset, but it set all the values in DP as infinity, and that should solve it. Ooh, that should not be -1. Okay, so DP is infinity size of DP. Then umbrella. We set umbrella I as XP. That makes sense. Okay, so AN, left, right, we see in left, right, then from J between L and R, range J equals 1. Okay, makes sense here. Then for M, we get in X and P, we see in X and P, and then just save it as X and P. Okay, that makes sense. Now we have previous min, which is 0. Then for I between 0 and A, int current min equals infinity. For J between 0 and M plus 1. Yes, we go through all the umbrellas. So if we are currently at an umbrella, oh my god, you're on J. Yeah, J dot first. Yeah, we're looking at the umbrella J dot first. That yeah, that if this is the current index that it works, then we do Ji J dot second. Else, yeah. If you're talking about umbrellas, we look at J dot first is less than I, then dpji equal dpji minus 1 plus J dot second. Else, if it's not raining, dpmi equal to minimum of dpmi and previous min. Current min equals min of current min dp. Here we go again. Ji. Perfect. Int ant equal int 0 and plus 1 ans min I a minus I. Answer equals infinity minus 1 ans. I should have just left it as ij. That would make it a lot easier to debug. Okay, yeah, 14, 45, minus 1, perfect. Submit, and this should be done. Voila.